arriving and being transported back to Kennedy Space Center. And I'm NASA Recovery Director Jeremy Graber here with me.
Thank you. Appreciate everybody coming out. This is truly a historic event. We had an outstanding support from the Navy to accomplish our EFT-1 mission. Orion is sitting safely inside the Anchorage, and we're all very proud of this team, made up of many organizations that came together to do a very amazing job to pull together the Navy resources, the NASA resources, to effectively accomplish our mission on time. And again, we're just really happy to be here, excited to offload Orion and get her on her way back to the Kennedy Space Center so we can start looking at the spacecraft and start digging into the different pieces of it to understand all the different parts that we put into this. That's it. Thank you.
Good evening. I'm Lieutenant Chelsea Irish. On behalf of ESG-3 Navy PA Lead, I would like to introduce to you our commanding officer of USS Anchorage. We've got Captain McKenna, and he's got our introductory statements for us.
Good evening, everyone. My name is Captain Mike McKenna. I'm the CEO of the USS Anchorage. And on behalf of the 430 men and women that make up that fine crew, in addition we have EOD Group 1, Helicopter Squadron 8, and the USS Salvor, all were participating with us in the last week and really over the last year in preparation for this event. It's been a real privilege and honor for us to work with Jeremy and his fine team at NASA to build this team and to be a part of what I think is a historical event and really the Navy's return to manned space flight. We haven't done this in almost 40 years and we're back. And so it's been a real thrill for all of us to do that. We couldn't be happier about it. We started this about a year ago, actually on the East Coast, working to get this whole process started. And then as we came to the West Coast, I actually started on USS San Diego, one of our sister ships. The USS Anchorage, the team standing over to my left, have been a part of this process now through URT 1, 2, and 3. That's our underway training event where we actually built the very complicated tactics and procedures we use to bring the crew module on board. And that all came to fruition this last week, and actually just an absolutely picture-perfect event. So on behalf of the Navy and the team that's been out here, the folks, the men and women that were on Anchorage, thanks again to Jeremy and NASA. Absolutely wonderful professionals. It was a great team that we built. We thoroughly enjoyed it. We've had a great time. We look forward to doing it again. Thank you very much.
Thank you very much, gentlemen. And at this time, we're going to go ahead and break into individual Q&A sessions. If I could have the single line move up closer to the microphones for the purposes of individual Q&A. The way that we're going to work this is we're going to give you 5 minutes with each representative. So please station yourself in front of the representative that you would like to begin with. Again, starting from left to right, could you all please introduce yourself, your name and your title for the purposes of the camera?
Good evening. I'm Louis Garcia, NASA Ground Operations Manager.
Hello, I'm Sean Quinn. I'm with the Ground System Development and Operations Program at NASA Kennedy Space Center in Florida, and my title is the Exploration Systems Manager.
I'm Jeff Angermeyer. I'm from the Ground System Development and Operations Program from the Kennedy Space Center, and I'm the GSDO EFT-1 Mission Manager.
Hi, I'm Sunny Williams. I'm from the Astronaut Office at Johnson Space Center.
Jeremy Graber, NASA Recovery Director for EFT-1.
Captain Michael McKenna. I'm the CEO of USS Anchorage.
I am Matthew Myers. I'm with the USG Unit 11. I'm a Navy Diver First Class there.
Good evening. I'm Goodwin O'Neill with Combat Squadron 8, Dep 1. We're providing the aerial support mission for this recovery process.
Good evening. I'm David Lance Second Class, Aaron Hill, also with Helicopter Combat Squadron 8. Two chiefs, I was on board helicopter 8, tracking the sea and possible. Myself and my counterpart.
Excuse me, man. That's very important.
No worries.
Hill, H-I-L-L. What
Attachment 1. Basically, I was operating as a liaison between the NASA recovery teams and the helicopters operating the debris tools, tracking where the CM and crew module and
Yeah, sure. Exactly. Yeah. This mission was awesome. You know, right from we needed to launch this vehicle, have it do its laps around the planet, and go pretty far away from our planet. You know, a lot higher than the International Space Station is, and come back and land and pick it up. This proves a whole lot of different things for us. It's going to give us a whole lot of data to create the next generation of spacecraft, similar to this one that's going to take humans farther than low Earth orbit. So this was a needed stepping stone. It's not absolutely, you know, the thing that we're going to actually put ourselves in quite yet. We have a lot to learn, but we needed to do this to take the next steps to make the next spacecraft.
It was described as picture perfect.
Exactly. Where it landed and its flight trajectory was absolutely picture perfect.
Yes,
and we're getting a lot of data from the heat shield and external parts of the spacecraft. The internal parts are not all ready to put a person in quite yet, and that's what I mean by we have still a lot more work to do, but this was a needed step to get us to the next step.
Now, as an astronaut, what does this mean for you personally?
Oh, this is awesome because right now, of course, we're going to the International Space Station. NASA is still manning the space station 24/7, but we're doing that on a Russian Soyuz spacecraft, and that's how we're getting people up there. In the next couple of years, we're going to have U.S. commercial companies, Boeing and SpaceX, who are going to make the spacecraft to go to the space station low Earth orbit. But this spacecraft is going to do a lot more different things. This is going to be able, on a larger rocket, going to take us to more further places than the International Space Station, and allow us as NASA to do what we do, is explore. So we're really looking forward to inspiring the next generation of explorers with this type of spacecraft.
What are the next steps then? I know, like, in the next 7 years, they're going to actually have a manned mission.
Absolutely. So, you know, the next one, hopefully we're going to develop the SLS, the Space Launch System rocket, and we'll put the next EM exploration mission on top of that. And that's the next one with that combination. Once we see that combination works well, then we're going to put people on it. So it's one step after another. We had to make sure that this spacecraft, this capsule, was going to be able to do its mission and re-enter. You know, the most dangerous parts are launching and coming back to Earth. The other parts, of course, are dangerous too. Having lived in space, it's a little bit unfriendly environment, but going up and coming back is really the parts that we need to make sure that there's no questions asked and we got it done correctly. And this spacecraft allowed us to make sure we understand the return really well.
Can you talk about your part in watching this whole thing go down? I believe you were on the ship. Talk about your experience.
Absolutely. Our office has been participating for quite some time, and we obviously have an interest in it because folks in our office are going to be the ones who are going to be riding inside eventually. So different people have come out, and I had the honor and privilege to actually come out here on the USS Anchorage and participate in this event and monitor and watch. And it's really just to get a feel for what it's like from the engineers, how they're designing the spacecraft, what their design plans are, and then having the experience that we have. I came back on a space shuttle and I came back to Earth on a Soyuz space capsule. Very different. Both the shuttle, of course, lands on a runway. The Soyuz lands under a parachute on the steppes of Kazakhstan. So very different landing parameters, and so sort of give that perspective when we're landing this one. How would it be like for crewmen who have been in space for a long time? Would they be able to be fine living in that spacecraft as it's landed in the ocean and floating for a little while? Would we want to get out? Would we want to stay in? How is the recovery process, and how are we going to interact with the rescue swimmers or whoever is going to be working with the capsule as it's getting recovered? So our role is really to observe and understand how it's designed and what the parameters are, and then provide any input that we can to make make it optimal for our guys, our Americans who are going to be flying in this thing.
And the conversation's all around Mars. Is that a reality? Are we really looking at Mars? I mean, we've talked about this all the time, but it's just so hard to conceptualize for us on the ground.
I say why not? It's a step-by-step process. You know, my background is test. I'm a helicopter test pilot, and we do things in steps, and this is one step after another. And like I mentioned, the heat shield is extremely important. It's a little different from coming back from low Earth orbit. You know, we're only about 250 miles above the planet, and this guy was about 3,000 miles above the planet. So the heating and the trajectory back to Earth are both different things, and we have to understand that to be able to take the next step to go farther. So I think what we're doing is we're getting there. We're on our way. You know, we have other rovers on Mars right now, so I think you know, why not? But we just have to do it the right way.
Right, or maybe not you in your lifetime, but maybe some people you work with, right?
Absolutely. I mean, I think it's going to be in my lifetime. I hope I'm going to live that long.
I hope so.
Maybe not my astronaut lifetime. I understand what you're saying.
Would you take that ticket? One-way ticket? Would you go?
One-way ticket would be tough. Actually, I was asked that by a kindergartner at one point in time, and I mentioned it'd have to be for a good reason. You know, coming back, my favorite planet is Earth, you know. Haven't seen it from space. It doesn't get much better than this one right here where you can jump in the ocean and take a swim. I don't think you're going to be doing that on Mars. But if there was a good reason and we are going to learn quite a bit about ourselves, our planet, and, you know, the universe, then I think most people would take that sacrifice if they had to.
You have some very extraordinary elite friends who are all astronauts. Are they jumping at the chance to go one way?
I'm not sure about the one-way thing. I think we'd have to go back and talk about that.
Yeah.
Fantastic.
From an architecture standpoint, are the astronauts actually involved with the determination of a habitat module, or if any other larger provisions besides the capsule itself will be required for a longer duration spaceflight beyond low Earth orbit?
We have some participation with the service module. You know, it's still getting all defined. The rocket and the capsule and the multiple parts that are associated with are still on the edges. They're out there. You know, we have in our office, we have a lot to do right now. We have folks that are training in the U.S., in Russia, all over the world for the International Space Station, as well as working with our commercial crew partners. So that's what's on our forefront right now. We're just starting to get more and more involved with Orion.
Right. You mentioned the commercial crew vehicles that are going to launch. Do you see a role for Orion as a backup to those to low Earth orbit in case those commercial properties do not pan out as expected? It was launched on a Delta IV rocket, looked really good going up into low Earth orbit. Do you think there's a potential that that may happen again sometime in the future, or is it being planned as a backup in case commercial crew does not work out?
Well, it's a long-term plan for Orion, so I'm not exactly sure about its near-term plans, except for it's heavy.
It is heavy.
If you take a look at it, it's a big capsule, and so it needs a big rocket to lift it, and it's going to need a big rocket to lift it with people in it. So I think our long-term plan, like I said, for NASA is exploration, and that's what we want to do with the spacecraft.
Very good, thank you.
Sure, I'm sure. My name is Sunita, S-U-N-I-T-A, Williams. Yeah, Williams. It's short for, Sunny is short for Sunita.
Okay.
Yeah, I'm in the astronaut office.
You are. So obviously you're with NASA.
Yes.
Tell me, you've got some big plans for Orion.
Sure. So it's a long-term plan. You know, right now we just wanted to make sure we can test this spacecraft and have it launch on a Delta IV, but that's not the long-term plan. The long-term plan is to develop the SLS, Space Launch System, a bigger rocket that's going to lift it, and then that combination, once we test that with EM1, the next flight after that, we plan to put people on it. It's going to do, it could potentially have the ability to do a lot of different things. Go do an asteroid, redirect, potentially go to Mars. We have a lot to do between here and there, so it's going to be a very exciting 10 years or so to develop those type of outward programs.
You have stronger rockets, but you'll still be using the Orion.
Yeah, the Orion, this capsule, that's why we launched this one too. We wanted to make sure we understood this capsule, the heat shield, and the external components for it as we continue to develop the rocket spacecraft combination.
Everything went great, didn't it?
Absolutely wonderful, as planned, yeah.
Now, talking about going to Mars. So people, there's a lot of talk about that kind of. When could that conceivably happen?
That's going to take a little while. Like I said, we're going to have to develop this other rocket. We're probably going to have to develop some other things that are going to be in association with it as it's going there. You know, I think that's a longer term program. So I think it's going to be a little while.
No idea of somebody said 2030. Is that realistic?
I think we're smart enough to get there. Absolutely. I think there's other factors that are going to need to get together. We're going to have public will and the funding that's associated with that too.
You know what? Bring the people back from Mars once you get it.
That whole program really hasn't been entirely developed that I'm involved in with yet. So I'm sure other people are thinking about it, but that's not on my docket right now.
What about comets and asteroids and that kind of stuff? Is that first up or what?
That's on the table. Asteroid redirect, absolutely. So hopefully we'll be maturing this spacecraft in the next 7 years, and we'll be able to do something like that.
How historic is it?
Okay.
From your perspective, talk about the historical. Just the whole mission.
Yeah, I think it's really historic. We haven't landed a spacecraft like this for quite some time, since the Apollo days, and so figuring out how to land a capsule back into the ocean and recover it is something that we haven't done in quite some time. And where it's going and how far away it's going from Earth, it's out of low Earth orbit, going up to 3,000 miles above the planet, going through the Van Allen belt, going through radiation, and coming back looking that wonderful. I mean, that spacecraft looks great for doing all of that. That's pretty amazing. So there's a lot of technology that has happened in the last, 2 decades, and we've been able to incorporate it into this spacecraft.
One last thing. We're looking at it right now. It looks like there's no damage at all. How do you see it?
It looks pretty good. I think it's probably a little bit better than expected from what I've been on the ship talking to a lot of the engineers and got a close-up look at the heat shield. Like I said, that is the biggest thing that we've been looking at. And of course it has a little ablation, but that's what it's supposed to do. That's why it is the heat shield. So it looks great. And one of the things that I hope this allows us to do is this vehicle is very heavy, and we have very conscientious about mass. And so I hope what we're doing is we design this very conservatively, and we'll be able to decrease those margins a little bit and then make it a little bit more capable. So this test flight will allow us, hopefully, to really get the program kick-started very well.
Thank you so much.
Sunny, John Dupree, KUSI TV here in San Diego. How are you?
Very nice to meet you. Great.
It's good to meet you. Can I get you to step over to our camera?
Sure.
If these folks are done?
I got one question.
One more
for
quick
you.
question for you.
Sure.
As somebody that I've seen the adulatory press coverage of you in India, where you're treated as such a representative of the country, and obviously this is something you've probably got a better concept than most people of how this is going to affect people around the world. What maybe a unique perspective as an astronaut, what would you say this is going to do?
I think this is amazing for everybody, because people realize that we're continuing. NASA is exploring. NASA is on the cutting edge. It's taking advantage of technologies that have been developed in the last 20 years and really putting them into a spacecraft. And I think it allows people to dream and imagine. Of course, we emphasize STEM here: science, technology, engineering, and math. And this is epitome of all of that. It's getting kids motivated, like, wow, there are possibilities. We have the International Space Station. It's not going to fly forever. It has a great life for another decade or so that we'll be doing science on it, but we want something more, that the kids that are in elementary school can put their hat on and go, you know what, we may even go to Mars in my lifetime. I could be that astronaut. And I think that's something that speaks to kids all around the world. So
I love the stuff
proud
you're
to
doing.
be a part of this.
I love the stuff you're doing with young girls in India. Please keep it going.
Thank you. Thank you. My real name is Sunita, S-U-N-I-T-A, Williams, W-I-L-L-I-A-M-S.
And your title, you're an astronaut?
Yeah, I'm an astronaut, yes.
Are you on the roster to fly on a future Orion mission?
Not yet. We haven't got that all squared away, but I'll be volunteering. Yeah, absolutely.
We got to run over here.
Okay. You mentioned real quick the recovery. You actually observe recovery there to kind of take some insights, and you mentioned your helicopter background as well. Do you know if there's any potential of actually using a helicopter in the recovery of the capsule to pull out of the water so it doesn't float quite so long, to keep astronauts from being exposed to the waves and the bobbing about while the well deck is flooded and the capsule is pulled aboard?
I think pulling the capsule out will be very difficult. But we are, you know, what we've learned from this, we're taking lessons learned. We're going to go back to the table and figure out whether or not what we did is what we liked. We'll have a lot of things that we did like, some things that we didn't like, and I think we're going to reassess and figure out whether or not we're going to do this a little bit different. And I guarantee we're going to do it a little different for sure. Probably not the exact same way, but there's a lot of things that we.
I had to ask. I'm a 12-year military helicopter guy, so.
Oh, that's a heavy.
I used to fly 53s, so 53E might be able to lift it.
20,000 pounds, and that's empty.
The 53K will.
Yeah.
Once it comes out. See ya. Thanks.
Thank you. How are you?
Operations program. We're taking the Kennedy Space Center and transforming it from to be able to support the processing and launch of the Space Launch System and the Orion Capsule.
Okay, very good. Are you involved at all with the with SpaceX's conversion of 39A into a commercial pad?
I am not.
You're not involved with that at all. How about operations on pads 40 and 41?
No, I am not.
You don't work those either. Okay.
The pad for our program
is 39B.
39B. Our major assets are our pad 39B, the vehicle assembly building, mobile launcher, the crawler transporters, and then a couple other facilities. In LC-39 and in the industrial area.
Okay. I know that the crawler, the mobile launch platform that was built for Ares 1 is now being turned into the mobile launcher for SLS.
Yes, sir.
Is there any chance of reutilizing any of their mobile launch platforms that were built for shuttle and making it into a second or possibly third SLS or commercial MLP?
For us, for SLS, there's no plans right now to convert it for SLS use.
Okay.
We are getting ready, if the center hasn't already done so, to advertise the availability of the mobile launch platforms.
Really? Okay.
Yes, if there's some commercial users that want to come utilize it, they can. We're also advertising the availability of the vehicle assembly building High Bay 2.
Really? Okay.
And so that is getting ready to come forward. One of the unique things that we've done in GSDO is we're making our facilities multi-user.
Right.
And so the pad, a lot of the design of the pad systems are such that we could launch SLS with its mobile launcher, and then if there's a commercial user who wants to use a mobile launch platform from the shuttle program, stack their vehicle, they can come out and use it. So we're freeing up one of our integration cells, mobile launch platform if they want it, and then they can fly off of our
Right. The orbiter processing facilities, the 3 bays that were already there, have they all been spoken for already?
Yes, they have.
All 3?
Yes.
I know that X-37, I think, is picking up one of
X-38?
X-38. X-38 was counted. X-37 was that's the Air Force One, the little tiny space plane. Who are the users for the other 2?
I can't speak for OPF-2.
Okay.
I know, I believe OPF-3 has been being utilized for Boeing for their CST-100.
Okay.
For their commercial crew entry.
Has any other organization bid for the multi-use part of 39B besides SLS?
Nobody yet. We're just getting ready to go advertise the capability with the mobile launcher and the VAB, and we're a couple years away from advertising the 39B launch pad capability.
Right. There was a Kennedy Space Center master plan document that was published online a couple months ago that showed possible development north of Pad 39, a potential horizontal launch landing facility, a vertical landing facility, and potentially even new pads. Any more concrete details on what might be going on up there or when that may take place?
No. Our Center Planning and Development Office has led that. They did an outstanding job with that master plan. They'd be able to give you the detailed specifics of that.
Okay.
But there are a couple, you're correct, there's a couple of launch pads, one south of Pad 39A and 2 north of 39B. At least sites that they've cited to be able to go.
I remember seeing a map that showed some different color codings for land use and such. Yeah, it was very unusual to see because I remember there were originally plans for a 39C and a 39D and such.
Yes.
Yeah,
we're bringing the fork down.
Okay, sounds great. I'll get out of the way then. Thank you.
Okay, thank you.
I'm going to ask you a couple questions about your role in the recovery. I was watching the online streaming video that was being shot by the drone overhead, and I saw you guys helicopters circling around the area more than once. What was exactly your role in the air when the recovery was taking place?
We had 2 aircraft airborne. One was primarily, they were both tasked with acquiring the crew module as it came through the atmosphere.
Okay.
We used the multi-spectral targeting system on the aircraft.
We've got some news stations going live in 5 minutes. I need everybody who isn't filming live to move away.
And then we switched to a day TV type feed, pretty much just like your video camera.
Right.
And then we're going to walk over. You want to call?
Yeah, let's just back up while these guys are Getting happier. So you guys, did you guys carry any extra rescue swimmers or anybody on board to kind of help out the folks who are in the water?
We had a third aircraft that was dedicated to search and rescue only.
Okay.
That was on the ship in an Alert 15 status that was waiting in case they needed either due to an airborne emergency, due to debris falling out of the sky and hitting an aircraft.
Indeed.
Or something in the water. Now, obviously, the NASA engineers have a debris tool that they've modeled every piece of equipment or every article that comes off the crew module as it comes in.
Right.
And it's a very accurate system. So there's a footprint that they go by, and they pretty much vectored us around that debris field to keep us out of the debris as we descended. One aircraft was, once the forward bay cover jettisoned off the capsule.
Which I heard was looked for but was lost, actually.
We actually found it.
You did find it?
We had it. We tracked it all the way to the water. We got on top of it, marked it. We had to get out from under the debris until it hit the water, and then once the debris field was clear, we could come back in. And in that 5-minute span, it sank.
It sank. It is a metal cover after all. So
it was about 1,200 pounds, and it was estimated to float between 5 and 30 minutes, and floated for about 5.
Yeah. Did you guys? Were you guys tasked to look for the other parachutes as well? I know one of the mains was actually lost during the.
The aircraft I was in was primarily tasked with the forward bay cover. The other aircraft was tasked with the crew module, tracking it after the forward bay cover jettisoned to the water, and then marking the drogue chutes and the pilot chutes. And of course, the main chutes were right there with the capsule.
Right.
Yes, one of them did sink immediately. The other two actually caught a little bit of air and stayed inflated long enough for the small boat recovery teams to get to the.
So those were recovered intact.
They were recovered intact.
You said you guys were tasked with actually spotting the vehicle before it impacted with the water.
Yes.
Were you able to use your FLIR to pick it up? At what distance? How far were you able to see it?
I can't remember the exact altitude. My MTS operator can probably tell you that.
Right. You guys have the FLIR on top of the nose, don't you, on your aircraft?
Ours is actually underslung.
Yours is underslung. Okay.
But once again, the air operations coordinator for this mission, Don Reed, calculated, he had us at 10,000 feet and 6,000 feet respectively, and he calculated pretty much the right angle to where the diving board or the mounting platform for that FLIR would not obstruct the view.
Right.
And we had several different points. We had 4 waypoints as it entered, and at each waypoint there was an azimuth and a heading that my MTS operators had to look at in order to acquire it. And we were acquired at about 90 seconds out from the planned point of acquiring it. So
how close to the simulations and the training was the actual recovery operation?
It was dead on.
Dead on.
I mean, the capsule was exactly where it was calculated to be based on our position. And if you look at the launch time and the splashdown time, it was calculated to splash down at 8:29 local, and it splashed down at 8:29 at 22 seconds local.
Amazing.
It was pretty fantastic to see, the results of a lot of different personnel.
No, that's excellent. Level up plan comes together like that.
Exactly, and how accurate they can be. So.
Did you guys, as aircrew, practice this in a simulator or anything before you actually deployed on board the ship to go to?
We actually did. HSC-8 has been involved in this since January of this year.
Okay.
We originally went out to Yuma Proving Grounds and witnessed a drop test out there in January.
The one that was out of the C-17 then?
Yes.
Yeah.
And then we came out with the USS San Diego on URT-1, and we did an aerial test, initially practicing acquiring the target with a G2 out of Dryden Test Center.
Okay.
Following that, we did another drop test in June, and then an underway period in September on the USS Anchorage.
Okay.
And then we were scheduled to do another drop test in November, just prior to Thanksgiving, to kind of give the MTS operators a little bit of practice and get them back in the groove of acquiring this thing in the air. However, that mission was moved, delayed until, I believe, December 15th. So because of that, we actually had the NASA guys come out to San Diego. They went over the different scan patterns with the MTS operators on the ground, and then the following day we actually got in the simulators over at North Island and practiced it in the simulator.
Excellent.
So that game day on December 5th, when it actually launched, these guys were spot on, acquired it 90 seconds out, and were able to provide imagery all the way to the water.
That's outstanding. Outstanding. What's the plan to maintain the corporate knowledge and the lessons learned on how this process worked due to the long interval between these flights?
Yeah, it's interesting you asked that, because we've had the same discussion amongst the teams. Obviously, 4 years from now, when this happens again,
everyone's going to be moved along.
Will be in different commands. There will be different personnel. Hopefully, there is some continuity within the NASA teams. But my teams, from the aircrew side, the pilot side, the MTS operators, we're getting together and we are generating lessons learned, a document to provide to NASA, so that the next time this occurs, it won't be such a steep learning curve for everybody. They may take those lessons learned and say, yeah, hey, we want to do it this way, but at least it gives them a basis, and they know that obviously after this we succeeded in the goals.
It can be done, exactly.
Exactly. So it's a starting point for them. If they can improve on it, great. But yes, there is definitely a
challenge
plan
there
to pass down the corporate knowledge to the future crews for this.
Do you know, as far as you've been told, that this type of ship will be the preferred recovery option for future flights?
I don't know that. I think it may be, but I can't answer that.
Do you know offhand, for this particular flight, how long between the time the splashdown occurred before you guys were actually able to bring the thing on board?
I believe it's splashdown around 8:30, and I didn't witness it come in, but I believe it was around, you remember, around 2000.
Okay.
I wasn't that late. It was way before sunset.
All right.
Yeah, like I said,
it got on board right around 5 o'clock.
Okay. Sounds good. So, one last question. Has there been any talk of involvement of possibly heavier lift aircraft in the future, say 53s, that would possibly...
They were considering that after URT-2, I believe.
Possibly sling loading the aircraft, the capsule itself.
The weight of it is just kind of, prohibits that.
Yeah,
now
roger.
There is a new 53 kilo coming out that may have a heavier lift capability.
Right.
But that aircraft is not in development or not in operation yet.
Yeah, it's a few years out.
That's going to be up to bigger brains than mine to figure out.
Yeah. All right. I appreciate your time. Thank you very much. Bye-bye.
Better understand what the end game was when we finally flew this and what the vision was. They really got excited, and this last underway, Jeremy and I were just talking about it. It was amazing how much teamwork, how much friendship had been built between us and our crew.
Excellent.
And they really did enjoy watching it come down. Everybody was excited for your folks, and it was working right, that everything turned out the right way, and to be a part of it, everybody was just thrilled. I mean, it was just, it was noticeable, the excitement on the ship when we caught it. We had a big dinner that night. Everybody sat around and talked, big ice cream social, and it was NASA and Navy having a great time together.
How'd you guys feel when it slipped 24 hours?
It was funny. Jeremy and I started talking about it a little bit. We're like, okay, so when are the windows going to be available, and how's it going to go? And we both said, well, I got 21 days of food on board, so as long as it doesn't go longer than 21 days, I think we're good.
Excellent, excellent.
But yeah, Jeremy was really good, and his whole team was very good about telling us, this is what's going on, this is what we think we're going to be able to do. Here's what we.
So the coordination was close then, and very effective.
Yeah.
From the actual operation as it took place out in the Pacific, how close was it to the simulations that you'd run with the boilerplate capsules earlier on in the year?
It was very much the same. The couple of things we didn't realize that ended up taking us longer, putting the horse collar on. We didn't realize that the honeycomb was pretty sharp.
Really?
So when they went to put it on, they were really worried about those lines getting cut as they pulled it around.
Okay.
So we ended up having to loosen it, and the chafing line around it took us about an extra 2 hours.
Right.
But once we got it behind got it attached, it got tethered up just like we practiced it. Everything laid out just like we practiced it. And once we got it behind the ship, it went very much like we'd expected it to do.
When the craft is being drawn into the well deck by the cables, or the ropes, I should say, is there anything behind the vessel actually keeping tension on it to keep it from being pulled in?
Yeah, so we had one of our 11-meter ribs that maneuvered it behind the ship, and then once it was back there, he applied just a little bit of back pressure.
Okay, is that an outboard powered vessel, or
it's one of those
jet drive inboard type things? Okay.
Yeah, the jet drive.
Okay.
So he just applied enough pressure to keep the line taut, and then he could maneuver the capsule around to make sure it stayed centered on the well deck as they put it.
Okay. Was there any provision of how to right the craft? If I know that, for example, not all of the bubbles inflated.
Right.
If it went into a stable 2 position instead of stable 1, how do you flip the thing back over, particularly if there's astronauts inside?
So it's a great question. The Navy dive team, Matt DeMeyer's a great person to ask about the training we did in the neutral buoyancy lab at Johnson Space Center.
Right.
In the pool there where the astronauts train for their EVAs on station and other EVAs, we were able to go demonstrate a capability, and these guys do this for all kinds of different salvage operations where they put inflation bags in the right positions. They engineer exactly where they need to go.
So external inflation bags could have been attached if required.
Absolutely.
Okay.
We had that, and we had that capability demonstrated at the pool, and we had all that capability to go do that if that had occurred for this mission.
Right.
It was a great opportunity for me when we finally saw Orion splash down. It was great for me to call splashdown, and we're in stable
one. Correct.
Because we had the capability to do it. It was very good that we didn't have to. It gave us an opportunity to not have to go do that extra work.
The men who are actually in the water, what career field are those guys from? Are they salvage divers? They are Navy divers.
So we're actually EOD, explosive ordnance demolition. So
okay,
there were a mix of different divers. But
and are those particularly those same men had been practicing with the boilerplate capsule?
And that was what really was important, I think, to the whole team. It was the same people coming back every time to do the job. So we had the same pilots from HSC-8. We had the same Salvor was our backup ship, same crew there. We had the same people working all our different line handlers, were always the same. And so we were able to build that consistency. And once we learned a lesson, we didn't have to reteach it. Everybody there got it. We just moved on.
How is that knowledge going to be kept fresh and the continuity kept with the long interval between the flights as currently planned?
So, from our perspective, we're capturing all the lessons learned that throughout each of the test events. We've captured those lessons learned, and we're building. We include that in our database that we collect all of our lessons learned on everything that we do.
Right.
We're also sharing and providing all of the procedures that we developed to go do this mission to the Navy.
Okay.
And then the Detachment 3 DoD folks that are they're our interface between NASA and the DoD.
Right.
Those folks also carry that lessons learned, so that if we're not on Anchorage next time and we're on a different LPD, then those folks will be able to get that same information. Each ship that has been involved with this to this point has essentially passed on what had been done on their ship to the next ship, and it's been great. I expect we to do the exact same thing.
Is it expected that an LPD would be the desired class of vessel for future recoveries like this?
As of right now, we've got some. There's some things that we're going to have to change and have to change to do this. It took us almost 8 hours at the time of the splashdown to get it into the well deck. That's got to be cut way back. But we have the capabilities on an LPD are unique. And they fit this mission very, very well.
Right.
And so we just have to figure out how to get that part of the process down quicker.
Is there a provision to potentially airlift the capsule with a heavy lift helicopter if called upon? Are there mooring rings, attachment points for hoisting on the vessel itself?
Currently that capability doesn't exist, but as we move forward and we're looking at all of the different options that play into that nothing's off the table.
Right.
We really need to focus on getting the crew, recovering them safely as quickly as possible. But in reality, this has given us a great opportunity to learn a whole lot about the environment that the ocean provides us. And so, from a spacecraft design, from a recovery techniques, from the ship that's at sea to support that recovery, we know a lot more than we did before we accomplished this, and we'll take it all into we'll take it all in and we'll move forward. That's really, my boss says that we're up on the line as well. That's what they're looking for me to be highly working towards over the next 6 months.
Are you involved at all with contingency recovery operations for the commercial crew vehicles? Supposing like a CST-100 or a SpaceX Dragon carrying astronauts had to land in the ocean, for example, due to an emergency. Who's actually working on how the plan would be to recover those capsules outside of a nominal splashdown?
I can't speak to that. Yeah. We're focused on.
You guys are focused on Orion.
Okay. And those guys have got. I'm sure they've got plans in place.
I'm sure. Okay. Well, thank you very much. Appreciate it. Thanks a lot.
Thanks.
Yep.
You mentioned all the awesome things going on there at the Cape. If I want to come down there and see what's going on, potentially write about it, how would I go about doing that?
Talk to Andrew, but I'll give you my card. You got a card? Yeah.
Yeah. You said last time I was down there in 2002, and I know you guys are in the midst of transforming that whole.
There's a lot to see.
Yeah. And launch not the ship.
Not much left at pad A or pad B.
No, it's a flat
done.
pad now.
It's a
basically.
clean pad.
Clean pad.
They call it a clean pad.
Well, wasn't that the Saturn V plane? It was a clean pad, more or less. Everything rolled out on the platform.
They unfortunately weren't able to execute it because they had to build this MST and all these other things.
Yeah, exactly.
The intent, at least what we learned from Shuttle, was the recurring cost to maintain the structures, a couple hundred yards from the ocean.
Oh God, yeah.
And so you can take a lot of those services that you need for the vehicle. You put them on the mobile launcher and put them back inside the VAV. It should help reduce the recurring cost because you're not out there getting land bias at all time. Plus, with that mobile concept now, wanting to have multiple vehicles on that pad, and we're working on our architecture to get to the point where our pad flow is no more than 7 days long. Whereas Apollo was, with Shuttle, they were like a month plus long. So if we do get other users out there, we're out there for a week, we launch, get the mobile launcher back, it's nice and easy.
How much life do the crawlers themselves have? Have they been upgraded?
Oh, we have massively upgraded.
Really?
Yeah, yes. Yeah, we spent quite a bit of money on all our transporters.
So that architecture is going to continue to exist now by using the
Yeah, we
crawlers.
went through lots of trade studies and did the math on alternatives, and the crawler won every single time.
Did SpaceX ask to use the crawler on 39A? I think you're doing something totally different.
No, they're going to use a rail system, the erector, just like they're using on the other pads.
Really?
Put a hip right outside the gate.
Yeah, in fact, we're building it right now. We're driving the pilot.
Really?
Yeah.
They put a heavy foam plate.
So
They're ambitious, man. I love the whole commercial vibe that's going on in this country right now.
Yeah.
It's such a nice portfolio how we mix with us going off to deep exploration and then taking over low Earth orbit and how we're contracting with it. It is.
And the neat thing about it, with SpaceX especially, is it's American design, American jobs.
Yep.
It's all being built in this country. Exactly.
Even with the Russian engine, that's what they usually get by.
We did it because it was inexpensive at the time. It was politically expedient, honestly. In the early 90s, it was nice to engage those guys and let's all be friends. So,
and they've been great partners to us. The
crawler.
You get outside of that the politics you see in the country, but when we went over this spring, they were nothing but genuine. They're just they're like us. They're rocket geeks, man.
I have flown Russian guys on board my helicopter Sandberg back in the early 2000s. Part of the nuclear inspection teams that come to look at the silos and such. They're good at this, honestly. Especially at the operational level.
I think people get intrigued in space exploration, but in the world, there's very few of us that catch the bug such that we want to go do something about it. And they've got a bunch of people we met are just like that. Just like that.
So you were saying about the crawlers, so quick?
Yeah, so the capacity Apollo and Shuttle is about 18 million pounds, or 12 million pounds. We're upgraded to 18 for the SLS.
It's 18 for the service.
No, it's carrying both the mobile launcher and the SLS.
Yeah, that's a lot heavier. Because now you're talking something, a core almost the size of Saturn V with two fully loaded SRVs strapped to it.
And those SRVs have two additional segments.
That's right, they're 5 segment turrets.
5 segments. And for the tower that Jeff was talking about earlier, we moved that fixed service structure from the pad. It's now back on the mobile launcher, so we got to clear all that up.
Right, it's a lot of
so
steel.
The limiting factor after the crawler's done upgrade was actually the catacomb release of the pad.
Really?
Yep. And so, we do have plans to reinforce them. And when we're done, we'll be able to have a rollout pad, the pad will be able to take up to 2,500 pounds.
Is there still thought to upgrading SLS to liquid boosters? I know those would be lighter.
Yeah.
Or is that kind of...
Well, it's in the trade space for future variants of SLS. And we've tried, when we redesigned the flame deflector, we redesigned it such that it could accommodate any exhaust system of any known,
solid or liquid,
of any known vehicle in production today. And we also did the models for variants of the SRVs.
Does the pad still have provisions for kerosene?
No,
it's not all gone.
No, it's all gone. It turns out it's not that expensive to re-implement. Kerosene is a much easier commodity to work with than hydrogen. Or oxygen.
Yeah.
So the systems you need for kerosene far less expensive.
That's interesting to hear that the liquid isn't totally off the table yet. I know that solid seems to be kind of carrying the day right now. Even when you go to the Block B with
the Block 2 trade space.
It is.
Yeah.
It's in the trade space, and we've got enough segments now to last us. How many? 8 sets?
Oh God, Russia, I don't know.
So they're going to reuse the shuttle segments and restack them into the 5-segment rocket.
Well, they've got cases left over for the shuttle program that they'll refill.
Okay.
The SRBs are not going to be recovered from this test.
Really? That's the first I've heard that. I thought they were going to still try to parachute them back.
Nope.
Just going to let them go.
Yeah, thank you. Thank you for coming.
No. That's the kind of big splash then. Yeah. That's kind of funny now that even SpaceX is going to try to start landing their cores on barges eventually back in SMAD. So.
Yeah, our flight rates.
Just not worth
Jeremy,
it.
I think he's going back Wednesday. And then,
well, hopefully I can be in touch and come down and see you guys sometime.
Well, it was a pleasure meeting you and talking with you.
Thank you. You guys had a great trip back to Florida.
Thank you very much.